unless I mess up. Welcome. So, graphing circles is what we're looking at today. If you know the equation of a circle, you can graph the circle by identifying its center and radius. So, we have the equation x plus 2 squared plus y minus 3 squared equals 9. We're going to graph it. You can either write it down or mentally, kind of in your head, rewrite it into the equation. But you want to remember that that plus 2 really is minus a negative 2 because the negative goes in the equation. So a plus 2 means that negative 2 is the x coordinate for our center, and a minus 3 means 3 is the y coordinate. If we take the square root of 9, we get our radius, which is 3. Now let's graph. So step 1, let's graph the center point, which is at negative 2, 3. Step 2, you're going to use your radius and count r units down, right, left, and up. The easy directions to go. So our radius was 3, so we're going to count to the right 3, to the left 3, down 3, up 3. You're going to take your compass and you're going to put it on the center point, and you're going to open it so it's the same width as the radius. And that looks reasonably good. And then you're just going to connect the points from the circle. And there we go. And that's all there is to graphing a circle. So they're super easy. We're going to do a few more examples. This one is not in your notes. It's also not in standard form. What would I have to do to put this in standard form? Well, since Anna's at the yellow table, anybody at the yellow table, Anna, what would I have to do to put this in standard form? And very softly she said, add x squared. All right, so we're going to add x squared to the other side. X squared plus y squared equals 36 is now in standard form. How about the center of our circle? Are these a good one? No. Anybody at the orange table?
The center?
Yep, what's the center?
That would be 6. Or, center, oh my gosh. That would be the origin.
Very good. Mark says the origin. He got it right. And how about the radius? These are good ones. Anybody at the green table? What's the radius of our circle? 6. All right, so now to graph, we just have to graph the center point, and then we count 6 up, down, there it goes, right and left. Put the compass at the center, and then you want to open it the same width as the radius. Oops, too far. There we go. And then just connect your points. And there we go. We've graphed our circle. Any questions so far? I think the next one is in your notes. So all of you in computer land as well as in the classroom can write this one in. So I want you to write the steps in on this one so we have it one time. All right, so you're going to identify your center and your radius. Step 2, you'll graph your center point. Step 3, you'll count r units, so r is the radius. Up, down, right, and left. You'll put the compass at the center point, open r width, whatever your radius is, and then just connect the points. All right, so just put that in your notes. Usually when I'm recording this and there's nobody in the room, I wouldn't even wait for you, but now I'm waiting for you. So. And then we'll graph this. So while you guys are writing it down, I'll find out the center and the radius. So orange 4. What's the center of our circle? Yep. So 3, 2 is the center. How about the radius of the circle? Orange 5. What's the radius of our circle? 3. All right, so now we'll follow the steps. We'll graph the point 3, 2. And then we just count 3 in each direction to the right. 1, 2, 3. And then to the left, 1, 2, 3. And then up. And then down. And then you just take your compass, put it at the center. There it goes. And you'll open it. It's the same width as R. I think that's a little too far because I think my point's just a little in the wrong spot. And that looks good. And then just connect your points. And that's it. And you've graphed the circle. Okay, so let me know when you're good with the notes. Everyone's got them down. So just for our absent people who are away on an FPLA trip, we're taping today's lesson. And we'll tape tomorrow's lesson. So tune back. Everyone good at the orange table? And yellow orange table good?
Yes.
Everyone green table good?
Yep.
Okay. Good. Everyone good? Okay. All right, so we want to graph this one. I'm not going to write the steps again. One time was enough. This one's not in your notes. Center of the circle, yellow 5. -4, 1 is correct, because remember that's a minus a negative. How about the radius, green 5?
Radius is 5.
Just take the square root of 25. So now we're going to graph the point -4, 1. And then we'll just count 5 to the right. 1, 2, 3, 4, 5. To the left, well, 1, 2, 3, and maybe right there. We're hoping that one's on the... We'll move the point if it's not in the right spot. 1, 2, 3, 4, 5 above and below. 1, 2, 3, 4, 5. Should show the equation that fits on my graph. So then we put the center there where the radius is. We want to open it so that it's the same length as the radius, about there. And then connect the points. And other than the one I had to estimate, it's all pretty good. So I obviously estimated too far. And that's all it takes to graph the circle. Okay. Let's do, I think I have one more, and then we'll look at an applied problem using the graphs of circles. Actually, 2 more. All right, so, because is this one in the notes? This one's not in the notes, or is in the notes. This one is in the notes. This one is in the notes. All right, so, is this the last one in the notes? Yeah. All right, so we want to graph this one. How about the center? Orange 2. -5, 0 is correct. How about the radius? Orange 3. Radius is 1. All right, so we're going to graph our center point at -5, 0. And we'll just count 1 to the right, 1 to the left, 1 up, and 1 below. It's a little itty bitty circle. We'll put the compass point on the center, and then looks like this one's a little too far over. Oops. Well, they kind of all want to be that. So we'll call that good. And we're going to connect our points. And not too bad. Maybe my circle is a wee bit too big, but now it's just about perfect. There we go. Magic of technology. So there we've graphed our circle. Any questions on graphing circles? Pretty straightforward. If you can identify the center and the radius, you can graph a circle. All right, so you all at home have this whiteboard practice, and the rest of the class will get it as well. Let's, on this one, a little review. We're going to write the equations of some circles here. This one's on the back of the notes, and I think it's the last thing for us to do. So if you can't read it up here, if you're sitting far away at home, you probably can read it just fine. You can see it in your notes. So blue 2, what is the center of circle A?
16.
And all the lines are going up by 2. Was it? 10. Yep, 16, 10 is our center. Actually, I'll just write it over here. So you can put that in your notes. How about the radius? The length of the radius is what? Blue 3. Each line's worth 2. 10. And how about the equation? Anybody at the blue table? So, what would our equation be?
X minus 16.
X minus 16.
Plus X minus 10.
Y minus 10.
Y minus 10 squared.
10 squared, yeah. And then we just square the 10, right? So we just replace the h in our equation with the x coordinate for the center, and the k in the equation with the y coordinate for the center, and then r is the radius, and we just square it. And that's all there is to write in the equation of a circle. How about the next one? Let's identify the center. Orange 4, what's the center of circle B? Right here. And it's in your notes as well. And each line is 2.
2.
So each line's worth 2. So if it's 2 lines, that's really... Patrick's getting the answer for us. Stay tuned. 420. How about the radius? Orange 2. Yep. Yeah, these A and B are congruent circles. And then how about the equation for our circle? Yellow 5. Yep. Right, so we just replace the h and the k with 4 and 20. And then the r with 10, and then we'll just square that out. So x minus 4 squared plus y minus 20 squared equals 100. And then the last one, how about the center? Orange 3. So this one here. Yep. How about the radius? Green 5. 12 is correct. And then how about the equation of the circle? Orange 5.
It would be x squared plus y squared equals
12 squared. Yeah. All right, so there's no reason to put x minus 0 and y minus 0. If you do, just drop that and just put x squared plus y squared equals 144. So when it's at the origin, we don't need to put in the center because there's no reason to put in minus 0. Any questions on writing the equations of circles given the graph? One last applied problem, not in the notes. So applying graphs of circles. A bank of lights is arranged over a stage. When a light is lit, it creates a circle of light. Right? So each light illuminates a circular area on the stage. A coordinate plane is used to arrange the lights using the corner of the stage as the origin. The equation x minus 13 squared plus y minus 4 squared equals 16 represents one of the disks of light. All right, so we want to, when you're putting on a stage production, what you don't want is to have your actors in the dark because no one can see them. All right, so you want to make sure that there's light on each of your actors. So we have 3 actors, and they're located as follows. Henry's at 11.4, Jolene is at 8.5, and Martin is at 15.5. Which actors are in the disk of light? The easiest way to solve this problem is just to graph the circle, and then graph the actors where they're located, and see, are they in the circle or outside the circle? All right, so here we have the circle that represents the light. All right, so its center, remember the equation was x minus 13 squared plus y minus 4 squared equals, was it 16? Yeah, equals 16. So each one of those goes up by 1. All right, so 13.4 is our center. Our radius in each direction is 4. All right, and if we graph the 3 actors, we have one at 8.5, one at 11.4, and one at 15.5. And you can see Jolene, well, you're in the dark. No one can see you. So either she's got to move or they need another light because then no one's going to see her. So the graph shows that Henry and Martin are both in the disk of light. All right, so if you have a question like this, the easiest thing to do is just graph it, and then you can clearly see who's in the light and who's in the dark. And I think that's the end of this lesson.
Yeah.
Right? So these are the closings. We had, that will have 3, right? 2 so far. We had the how to find the center and radius, so you have to rewrite using completing the square, and then explain how to graph the following circle. Number 18 here, so if you're watching this, and I'm going to tell everybody, I changed the problem ever so slightly on the homework, on the classwork, because you end up with fraction values, and, well, yes, I know you can figure it out. My intention was for you to practice the steps for writing the equation of a circle, not necessarily to practice your ability with fractions. So I changed it ever so slightly. I changed 36y to 32y and 5 to 8, and that'll give you all whole numbers when you work with those. All right? So if you've already done the problem at home because you got it early with the numbers that were there, that's fine. If you haven't done it and you want to change it, here's the change. All right, and that's the end of the podcast. See you tomorrow with volume. Bye.